Hey guys, welcome back to the Year 9 Trigonometry topic review on page 25. Now, the first one, question 25 says a ship leaves port and sails due north for 115 kilometers, then turns and sails 175 kilometers due west. Find the distance and bearing of the ship from the port. Okay. So I'm going to put question 25 down here and draw the diagram. So a ship leaves, okay, so here's the port, and the ship has traveled due north about 115 kilometers, and then it turns left and travels west, and this is 175 kilometers. Okay, so this will be a 90 degrees. Now from the port, so we're at the port, we're looking towards the position of where the boat is. Here's the boat. Okay, and it says find the distance and the bearing. So to find the distance, I'm going to call this distance x. To find the distance, we're going to use Pythagoras. So we can say x is equal to the square root of 115 squared plus with 175 squared. Now if you have any questions on why this is the case, I'll just give you a quick Pythagoras revision here. You got a squared plus b squared equals to c squared, so that means 115 squared plus 175 squared equal to c squared, which is x squared. So therefore x is equal to the square root of all of that. Okay, so that's, I do it straight away like this in my head. So, but if you're wondering, that's where it came from. Anyway, you put all of that directly into your calculator. So let me just do that real quick. 115 squared plus 175 squared, and I got the answer to be 209.40 kilometers. Now the bearing. Okay, we need to know this angle here. Let's call this angle, I don't know, theta. Okay, so we need to find it, and because the bearing, when it says the bearing is normally referring to the true bearing, which is this angle that's like this. It wants that angle. Okay, but to find that angle, you need to find this angle first and then take it away from 360. You need to find theta first. So let's find theta. Okay, we can use trigonometry again. We can say, okay, this angle, we got this length and this length. Okay, so this length, 175 here, is gonna be your what? Your opposite. And 115 is going to be your adjacent. So, whoops. Let me just get rid of this. Alright. Anyway, so what we're going to do is we're going to say what you want to do is opposite over adjacent, and this is equal to tan. So tan of theta is equal to opposite, which is 175, over adjacent, which is 115. So therefore, to find the angle theta, we must do tan inverse. So tan inverse of 175 over 115. Put that directly into the calculator, and let's see what we get. 175 over 115, oops, 115 equals to, I got the answer to be 56.69 degrees. Okay, now that's not our answer, that's just theta. What we want is the angle, the reflex angle that's on the other side of theta. So to do that, what we're going to do is we're going to take 360, take away theta. which means 360 take away 56.69. And just put that directly into the calculator. Take 360, take away the answer, the ANS button, and you're gonna press equals, and you will get the answer to be 303.31 degrees. And there's my answer for both of them. So we got the bearing and we got the distance. This is your true bearing. Okay. So that's for question 25. Now moving on to question 26. You can pause the video anytime and if you want to have a look at it. Okay, so question 26 says Tatum drove 74 kilometers on a bearing of 138 degrees. How far east did she drive correct to 1 decimal place? So here's where, so this is question 27. So we have her position, starting position there, and this is her north. Now a bearing of 138 degrees looks something like this. This is your south, so 138 is past 90. This is 90 degrees. Okay, this is east. So we've passed 90 degrees. We've gone a little bit more, and we're over here somewhere. So that means you drove out this direction, and she went 74 kilometers that way. And this is her car. Okay, now it says how far east. So the question really here, I'll draw this in blue. How far east did she travel in the east direction? How far did she go that way? So that's what we're looking for. I'm going to call that X this time. Okay. Now what do we know? We know we have we got 74. We got X. Now we need to have some angles. If you want to use now this will also be 90 degrees. So imagine that's a triangle there. Okay. Okay, so we know this is 138 altogether. Now this is 90 degrees. So what's this angle here? It'll be 138 minus 90, which will give me 48. That's 48 degrees. Now I can, from this I can conclude that I can work out what this angle is. This will be what? 90 minus 48, or you could do 180 minus 138. That's another way, because it's a straight line. 180 minus the 38, you get this angle here. Let's call it theta. Okay. Or you can do 90. Okay, 90 degrees, because this is a 90 degrees from here to here. Minus 48, and you get this angle theta as well. Same thing. Right. Anyways, so when we minus it, we're going to get 42. So that angle there is going to be 42. Okay, let's get rid of this. So this angle is 42. And then we can use that to work out our distance X. Okay, you could say, well, this angle 42 and X is going to be opposite, so opposite, and you got, what else? Got this 74, which is your hypotenuse, so opposite and hypotenuse. Which trigonometry ratio is opposite and hypotenuse? I think that's sine. So sine of 42 is equal to X over hypotenuse with 74. You can do that, or there's another way. Okay, I'll show you the other way. You can look at the diagram and notice that, okay, this the east line is parallel to this east line down here. Now, since these are two parallel, therefore this angle must be equal to this angle, which is also 48. So because that's 48, I can use this triangle here. Okay, I can use this triangle and say, let me see, cos of 48 is equal to what is it, X over 74, because cos is adjacent over hypotenuse. Okay, So there's two ways to work this out, and they'll give you the same answer. Okay, so I don't know, I'm going to choose one of them. You can choose any. I'm going to choose the bottom one here. So I'm going to say cos of 48 is equal to x over 74. So how do we find x? Okay, so from here you have to rearrange the equation. So how do I do that? What's happening with x over on the right hand side? X is being divided by 74. So to get x by itself, we need to remove this, get rid of this 74. So if you divide it by 74, you must times it by 74 to get rid of it. Now if you times the left hand side by 74, you must multiply the, if you multiply the right hand side by 74, you must multiply the left hand side by 74. So on the left hand side, you're going to get 74 times the cos of 48, and that's going to equal to, this will cancel out, this will be x. So put that directly into the calculator, and you're going to get 74 cos 48, and that's going to equal to 49.5. Okay, because it says to 1 decimal place, so that's what it is. Now if you had done it the other way, let's try this one. You could say, okay, if you multiply both sides, if you multiply both sides by 74, you're gonna get 74 sine 42 is equal to x. So put that into the calculator and see what you get. 74 sine 42, and again you're gonna get same thing with 49.5. They're exactly the same answer. Okay, so whichever method you use, you're gonna get the same answer, and this will be kilometers. Alright, question, hope that helps if you understand that part. Now question 27, let me just turn this off. Oh, actually let me turn this on so you can have a quick look at this. If you want, you can pause the video. I'm going to move on. Alright, question 27 says, what is this? Oka Hill is due south of Eastern Valley. Okay, so let's draw this. Question 27 is due south. Okay, so here you have Oka Hill. It's due south of Eastern Valley. So Eastern Valley is on this side. Due south. Oh, whoops. No. Never east. Okay, so here. Should be here. Here's Eastern Valley. And okay. Alright. So Oka Hill is directly south of Eastern Valley. Jacksville is 107 kilometers due west of Eastern Valley. So due west. Okay, so that means on the west side of Eastern Valley, you got Jacksville, and it's 107 kilometers. Okay. And on a bearing of, Jacksville is 107 kilometers due west of Eastern Valley, and on a bearing of north 13 degrees west from Oka Hill. Oh, okay. So that means, okay, let me just draw this a bit further down. So here we got Oka Hill. Now, let's color this in blue. If you're Oka Hill looking towards Jacksville, it says Jacksville is on a bearing of north 13 degrees west. So from Oka Hill, okay, this is north, and is west, so north 13 degrees. So this is 13 degrees right here. North 13 degrees west. If you're at Oak Hill looking at Jacksville, that's the bearing. Okay. It says find correct to 4 significant figures the distance between Oak Hill and Jacksville. Okay. So we're looking for this distance here. Well, I'm going to call it X again. So that's what we're looking for. So let's see. We have a 90 degrees here. We got a triangle, as you can see. Okay, we have all the necessary information. We're going to use trigonometry, and we're going to say, okay, well, let's look at this 13 degrees. 13 degrees, and this one, that's the opposite. So 107, the distance 107 is opposite, and then you got hypotenuse. Again, opposite and over hypotenuse, this is sine. So we're going to say sine of 13 degrees is equal to opposite, which is 107, over hypotenuse, which is x. These are the two numbers that we're interested in. Okay. So how do you find x? How do you find x? Yes. Okay. So let's now we want x. Our mission is to get x by itself. X equals to something. Okay. At the moment, x is at the bottom of this fraction here. So how do we get to the top? So let's multiply each side by x. Okay. So on the left-hand side, you're gonna have x sine 13 degrees is equal to. Now on the right hand side, when you multiply by x, this cancels out and you're going to get 107, isn't it? Right, so now I want x by itself. I don't want this 13 sine 13 degrees to be there. So what I'll do is, at the moment, what's happening? Okay, at the moment, x is being multiplied to this sine 13 degrees. So let's divide both sides by sine 13 degrees. Divided by sine 13 degrees. Divide this one by sine 13 degrees. When you divide it, you're going to cancel that out. So you're going to get x is equal to 107 divided by sine 13 degrees. Put that into the calculator and let's see what we get. It's 107 divided by sine 13, and you will get 475.659. But it says, so that's our answer. It'll be in kilometers. Whoops. But it says correct to 4 significant figures. So 4 significant figures. 1, 2, 3, 4. So the answer is going to be 475 point. Now we have to put it this last number, but the next number is a 5, so we have to round this up to a 7. It's no longer 6, it'll be 7 kilometers. There's your answer. Okay, question. So that's done. Okay, the tricky part was to getting. Let me see. The tricky part about this question is to understand how to get x by itself, to get x at the bottom of this fraction, to getting x to the top, which is x equals to 107 over sine 13. Okay, that's the tricky part. All right, moving on to the next question. Actually, we'll move on to the next page. Okay. Question 28. A pilot flew his light plane 240 kilometers due east from F to G. Okay. So he went due east. So he starts from here. Whoops. Whoa. So he starts from here. He flies due east. So he flies east in the east direction. 240 kilometers. From F to G, and then flew 475 kilometers due north, so it's this way. Actually it's a bit longer, like this. Be 475 kilometers due north. to H, to this point H. Find as a true bearing the bearing of H from F. So from F, we're at point F. So A, you're at F, and you're looking to H. So you're looking this towards H. Now the question is, what's the bearing? And what kind of bearing? They want the true bearing. So the true bearing, that means that we need to establish the north line, and then we can find the true bearing, which is from the north to whatever the angle is there. So we need to find this angle theta, and that's a true bearing. All right. Let's see. To find theta, we can find this angle here. This is also theta as well. Again, I'm gonna do this blue line to show you that this line and this line are parallel. If that's parallel, then this angle must be equal to this angle, because these are called alternate angles, okay? And that's the reason I put theta and theta there. So let's go back to this. So I can use, let me just redraw this triangle, which looks like this. Okay, you got theta here, you got 4, 7, 5, and 2, 40. We can use tan, because tan theta is equal to opposite over adjacent. Okay, so opposite is 240, adjacent is 475. And now we can find theta. We can say theta is equal to the tan inverse of 240 over 475. So theta is equal to, so on your calculator, just do shift and then press the tan button, and that'll give you the tan inverse. And do 240 over 475. There'll be a fraction there, and then just press equal, and you're gonna get 26.81 degrees, or round up to 2 decimal place. And if that's theta, then that means this is also theta. So that means the true bearing is going to be 0.26 point. Is it, how many decimals do they want? I'm just going to put it 2 decimals, so it's going to be 0.26.81 degrees. There's your answer for A. Okay. Now B, from says F from H. Oh, okay. It's F from H. So that means, let me just move this down a bit. Okay, I'm going to color this in blue, so hopefully it's easier to see. So you're from H. Okay, you're looking towards F. So what's the bearing? So first we establish the north line again. This is the north. Now the true bearing from H to F is, you're going to go in the anti-clockwise until you hit that line. And that's the true bearing. Now we know that this angle here, I'm going to color this in blue. So theta we know to be 20. Let me just rub this out. This is theta, and this is 26.81, which means that this angle here will also be 26.81. So what's the true bearing? The angle here, 26. So that means that we have to, the true bearing is going to be, let's go from here all the way to here. If you hit this point, that's 180 degrees, right? 180 degrees plus with 26.81, and we can find out what that whole angle is. So you do, let me see, this is question A. So question B is going to be 180 degrees plus with 26.81. And that's going to give me 206.81 degrees. There's your answer for B. Okay, I'm gonna get rid of this. So pause the video if you need to. Next question. Question 29 says Suji walked on a bearing of 295 degrees from home H. So let's establish that she lives at this H is her home. And 295, so let's see, which quadrant would that land in? Let me just draw the quadrants. Whoops. Okay, so this is H, this is where she lives at home. Now, this will be 90 degrees, 180, this will be 270. This is more than 270, so it has to land in the last quadrant here. Okay, so 295. All right. So we need to establish where that is. So 270, 295 is just a little bit more than that. So around about here in this angle. Now this is your 295 degrees. That's it. That's it there. All right. She goes from that to P, to the point P where the park is, to meet her sister. Together they walk on a bearing of 205 to the beach. Okay. So from this point, from the park, they go to the beach on a bearing of 205. Now, where's 205? So again, I'm going to draw the quadrants. So this is 90 degrees. Okay, this is 180. 205 must be just a little bit more over here. So it's in that direction somewhere, like that. Okay. So I'm going to draw, this is the north. So 205 should look something like this. And they walk to the beach. So let's pretend the beach is over here. We call it B for beach, which is 308 meters. Oh, okay. 308 meters due west of their home. So the beach happens to be exactly west of their house, of their home. So somewhere here. We're going to be at 205. Yep. B, which is 308 meters. So that means 380 meters is this one here. So 380 meters west. So she has to go to the park first to meet her sister. Then she goes to the beach, which is over here. So I drew this part too long. So that's supposed to be like that. Now it says show the angle PB is 90 degrees. Oh, okay. So the question is asking, prove that this is 90 degrees. Okay, no problem, no problem. Let's establish a couple of things first. So now, how do I draw this more accurately? Okay, I'm gonna draw some lines to help you see. Nope. Okay, so we need to see what angle we have here. First of all, man, my drawing is not very good. Okay, I'm gonna do it again. Okay. So this is question 29. All right. So this is the home, and the bearing here is 295. So this is her north from the home. This is the north line, and this angle is 295. So what angle is this? The remaining angle. So take 360, take away 295, and that'll give you 65 degrees. All right, so this will be 65 degrees. All right, let me get rid of this other one here. And this will be the point, the P for the park. Now, actually, let me just put it here. Okay, so from the park, I'm going to draw the north line as well. Now, from the park to the beach, it was like this kind of angle like this. Okay. and this is due west, and here's the beach. Alright, let's draw some imaginary lines. Okay, so now we know that it's 205. This, so from north all the way down here will be 180. Now what's this angle here? What's this angle to make? Because we know that for altogether the bearing is going to be 205 degrees. So what's that missing angle there? 205 take away 80 is how much? So we need to find, if I just draw this angle line down here, this will be your west, sorry, south, this will be north and south. This will be 205 take away 180, and that'll be 25 degrees there. You need to know that's 25 degrees. Now I want to find what this other angle is, and if I can prove that these two angles add up to 90 degrees, then I've done the first part. Okay, so what's that angle there? Okay, we know. Now I'm going to draw this in blue so you can see a bit more clear. This line and this line are what? Parallel. Okay, if they're both parallel, that means that this angle and this angle is equal, because alternate angles, right? So this must be 65 degrees. Okay, so 25 degrees plus 65 degrees is equal to 90 degrees. There we go, we proved it, we showed it. You can just draw the diagram, and you can say that, you can call this angle, here I'll go try and draw this. You can call this angle alpha and this angle beta, and you say, alright, well, angle alpha is equal to 180, whoops. It'll be 205 take away 180, and that'll give you 25. Then you can say angle beta is equal to, it'll be equal to 65 degrees according to the diagram, because the two north lines are parallel, and there's alternate angles. And then you say alpha plus beta equals to 25 degrees plus 65 degrees equal to 90 degrees. Therefore, angle HPB is equal to 90 degrees. We just proved it. Alright. Now the next part, let me get rid of this. Whoops, wrong one. Okay, question B. It says, find correct to the nearest meter the distance between Suji's house and the park. Oh, okay, right. I forgot to write one more thing. Okay. The distance between the park and the beach was 300 and I think it was 380. 380 kilometers. Now, we want to find the distance between the house and the park. So this distance here we're going to call X. Okay, that distance. Right, so how are we going to do that? I'm going to extend... I have to make a right angle triangle somehow, okay? Because trigonometry requires right angle triangles for now. Later on, it can work with any angles. I mean, with any triangle. But for now, we need this right angle triangle. Okay. So here's the right angle triangle. We can use, you see this triangle here? I'm gonna see if I can, we're gonna use that triangle, okay? Going back to this question here, I made a little mistake, so I have to fix this up. Now, it says Question 29b says find correct the nearest meter the distance between Suji's house and the park. That's what we're doing here. We're doing the x there. That's what x is. Okay. So what we're going to do is we're going to find x. Now we know this triangle. Look at this triangle here. Redraw the triangle. Whoops. Nope. So redraw the triangle. Looks something like this. Now this one we've already proved to be 90 degrees. Okay. So if that's 90 degrees, now what else do we have? Oh, look here. Okay. You got, this is the true north of the home. And this, we found out this to be 65 degrees. So that's 90, 65. This is 380 meters. And this is x. Oops, this is x. So what we're going to do is we figure out this angle here. What's this angle? This will be 90 minus 65 will be 25. This will be 25 degrees. There we go. We have all the things we need. Now this is a right angle triangle. So you can see that we're gonna compare everything here. We're gonna, so from this angle, this 380 is the adjacent. So adjacent, and this x, oh whoops, no, sorry, that's not the adjacent. That's the hypotenuse. Okay, there's a longer side. Okay, the longer side there of the right angle triangle. So that's the hypotenuse, and also we have the adjacent. That's the adjacent. So x is the adjacent. So adjacent over hypotenuse would be your cos. Whoops. Okay, so that means cos of 25 degrees, cos of 25 is equal to adjacent, which is x, over the hypotenuse, which is 380 meters. Okay, so therefore we want x by itself, so we need to get rid of this 380. What's the 380 doing? It's dividing. So we need to multiply to get rid of 380. Multiplied by 380 to both sides. And you're going to have 380 cos 25 is equal to x. So this is, so on your calculator do 380 cos 25, and then you'll see what it is, what the answer is. So 380 cos 25. And that will give you the answer of 344.39.4. Okay, there you go. And this will be in meters. Now, if they're asking for the nearest meter, this would just be, the answer would just be 344 meters if they want the nearest meter. Okay, otherwise it's this answer in 2 decimal place. All right. Now we move on to question 30. So question 30 says a surveyor standing at point X. Oh, they actually gave us a diagram. Excellent. Okay. Let's see. At point X sights a tower 840 meters away. So tower T. On a bearing of 37 degrees. So that means from X we're looking at a tower is 37 degrees. He's up 37 degrees. A second surveyor standing at point B. Okay, so this is a second person. He's standing at point B. Let me see. At point B, 365 meters from X. So that means that this is the distance from X to B is 365. Was it meters? Yes, meters. From X measures the bearing of X from his position as 307. Okay, so what that means is this. Let me just redraw this a bit bigger. So you have X, some person standing at X. Okay, looking at the tower. Tower here. This is tower T. Alright. And this is on a bearing of, so this is the north line from X, 37 degrees. And then you have another surveyor at point B. Okay. And this surveyor is 365 meters away from X. And it says, what else? The bearing of X from his position is 307 degrees. So what that means is, from B's position, looking at X, this is 307 degrees. So that means this angle here, right, this is the north. This angle here would be 307 degrees. Alright, show that angle TXB is equal to 90. TXB. Okay. TXB. Alright, so if we were to... it says prove this angle is 90 degrees. That's what it's saying. Alright, how are we going to do that? Well, let's see. Let's draw some lines to help us. So if I draw a line here, move that down a bit, and then continue, maybe draw this line, continue this line all the way down. Okay, continue this one all the way down as well. And maybe draw another, this one here. Now all these lines are parallel to each other. Okay, so the straight line that goes, the vertical lines are parallel, and the horizontal lines are parallel to the horizontal lines. Okay. So, if I think it might help if I find this angle here. I'm going to color it in blue. I'm going to call this angle theta. Now this angle theta is also going to equal to this angle theta. Again, the reason is because these lines are parallel, right? And those two angle thetas are alternate angles. That's why. Alright, so let's find angle theta first of all. So we know that the angle theta is equal to 360 minus 307 degrees. And that will give you 3 to 10, it'll be 53 degrees. So angle theta has to be 53, so I'm going to rub it out now. I'm going to put 53 degrees. And this one will also be 53 degrees. Alright, what next? Now, I need to prove somehow that this angle is 90 degrees. Okay, so this is 37. Look at the top part here. This angle is 37. And what is this angle here? Let's call this angle. Let's call this angle from here to here. Let's call it alpha. Okay, and let's call this angle here, the double line one, call it beta. So how do we find alpha? Well, we know this is a 90 degrees here, between here and here, right? And this one is 37. So alpha is equal to 90 minus 37. And that'll give you, let me see, 3 to 40, 53 degrees. Alright, so alpha equals to 53 degrees. Now beta. What will beta be? Alright. So we know here we have another 90 degrees, right? Another 90 degrees there, between there and there. Now this is 53 degrees, so what's the other one? So beta is equal to 90 minus 53 degrees, which is equal to 37 degrees. So therefore alpha plus beta is equal to 53 degrees plus with 37 degrees, and that will give you 90 degrees. There you go, I proved it. Alpha plus beta has to equal to 90 degrees. And it says there, show that's the case. So if you get this kind of question, you can just say, okay, I'm going to make, you can label that one alpha, that one beta, say that alpha is equal to this, beta is equal to this, add up to 90 degrees, there, done. Now, next one says, find the bearing of the tower from B. From B. So, let me just get rid of all that. Oh, okay. So the bearing of the alpha from B. Okay, so you're at the point B and you want to find out, oops. You want to know what the bearing of this point to the tower is. What the bearing is. Okay. So that means that, how do we do this question? Now this is tricky. This is 90 degrees. Okay, let me think. Now this angle, oh, hold on. Oh, okay, that actually helps because here, look, if I turn this around, right? Okay, now some of you might assume that the point B might lie somewhere over here. Like if you draw it incorrectly, if you draw this diagram incorrectly, you might think that X is here, T is here, and B is somewhere here, B. Okay, and you think, oh, well, that looks, you know, it looks like the point T is due north of B. Therefore, T is due north. Okay, you cannot assume this. You don't know where the B is positioned at. The B could be a bit shorter, so maybe it's over here. Okay. And the angle might be like this. So you have to find the angle, which is like the true north angle, which is like that much, some small amount degree there. So we can't assume that it's due north. We have to draw the line connecting the point B to the tower point T there. And then we're going to turn this around and say, oh, well, look at this. We have a right angle triangle. Okay, that really helps. So we have the right angle triangle and we have, this one is 90 degrees. We have this length here. What else do we have? Do we have anything else? Do we have another angle somewhere? 365 and... Oh, okay, yeah, I forgot about this first part here. A survey standing at point X sights a tower 840 meters away. So that means that, I didn't write it in, I should write this in before, but this is 850 meters. Awesome. Now we have all the information we need. Right. Now, we need to find this angle here. Okay, this angle here. How do we find this angle? So let's call this angle theta. So I'm going to say, if you look at the triangle, you can see that angle theta, there's opposite and there's adjacent. So opposite over adjacent, that's the tan ratio. So we say tan of theta is equal to opposite, which is 850, over adjacent, which is 365. Okay, so therefore theta is equal to tan inverse of 850 over 365. So again, on your calculator, do that. Let me see, tan inverse of 850 over 365, and that will give you 66.76 degrees. Alright, now it says find the bearing. Okay, now this is the tricky part. This is the very tricky part. Okay, we know that angle is 66.76, so let me just get rid of that and put this one back in. Okay, and I'll show you something. So from here to here, whoops. Okay, let me go back here. I'm gonna draw a black line from here all the way to here. Alright, so we know this whole angle we just worked out to be 66.76 degrees. Okay, but look at this thing here. From here to here is 53 degrees. Okay, so we need to find out what this angle here, this part here, what the angle is. This tiny angle here that's missing. So we say, okay, well, 66.76 degrees minus 53 degrees, and you will get 13.76 degrees, and that will be your true bearing of the tower from point P. So you're at point at point B. You're at point B, and you're looking at the tower. Okay, so let me just redraw that if that looks confusing to you. So you're at point B, and you're looking towards the tower T. Okay, this is the north line, and this is the other. So we know, again, so I'm going to draw this angle. This angle here we found out to be 66.76 degrees. And this angle was 53 degrees. So therefore, this angle here, that's between the north line and the tower, is 13. So I'm going to write this. So that's 13.76 degrees. So that's the true bearing, 013.76. Does it want it in nearest? No, it doesn't say nearest anything. So that's, I will leave it just like this. Okay, and that'll be a true bearing. And that will be the answer there for 30B. All right, that was tricky. That was kind of tricky, but in the end, it's solved. As long as you draw the diagram, you can see it there. All right, hope that helps.